Exposed surface effects on the thermodynamic and electronic properties of the lithium lanthanum titanate. In this work, we studied in the density functional theory framework the thermodynamic stability and electronic properties of the lanthanum titanate and lithium lanthanum titanate perovskite 001 surfaces. The results show that LTO surfaces are more stable than LTO surfaces, since their surface energies are 3.161 and 4.197 electron volts respectively. Besides, the surface ground potential suggests that the LTO surface with a titanium dioxide termination is more thermodynamically stable than the one with a lanthanum oxide termination. Similarly, among the titanium dioxide, lanthanum oxide, and lithium oxide terminate LTO surfaces, the lanthanum oxide termination is the most thermodynamically stable, whereas the formation of the titanium dioxide termination is less likely. Finally, titanium dioxide and lithium oxide terminate of LTO surfaces are metals because the surface reconstruction changes their electronic properties in comparison to the LTO bulk phase. Likewise, we observe that the charge electronic redistribution influences on the electronic behavior of the titanium dioxide and lanthanum oxide terminate LTO surfaces, semiconductor and metallic materials respectively, as well as the lanthanum oxide terminate LTO surface semiconductor. Introduction. It is desired that the LTO and LTO thin films have a good electrical conductivity at the electrode-electrolyte interface, since it would facilitate the electronic transport in both electrodes, avoiding the use of conductive additives that increase the unit resistance and consequently hindering the passage of the lithium ions. Thus, it is fundamental to study the change of the charge density at the surfaces on the thin films. Consider how this electronic density could be modulated depending on the exhibit termination at the surfaces to ensure that the electrolyte has a high concentration of the charge carried at the electrode-electrolyte interface. Usually, these free electrons at the electrode-electrolyte interface are caused by the reduction of the cations of titanium plus 4 to titanium plus 3 on the surface. Experimental studies revealed that the 12 and 24% concentration of the titanium plus 3 cations increasing to the LTO electrical conductivity 3 orders for magnitude compared to the 0.1% concentration without modify the lithium unit conductivity. Thus, we investigate the electronic charge redistribution and the 001 surfaces of the LTO and non-LTO electrolytes as a function of the excited termination, titanium dioxide, lanthanum oxide, and lithium oxide, and looking for the largest charge density and thermodynamic stability to ensure manufacturing. Model. In Figure 1, it shows the optimized structure for uh, different terminations with 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 titanium dioxide and lanthanum oxide or lithium oxide surfaces. The violet, green, blue, and red spheres represent the lithium, lanthanum, titanium, and oxygen atoms. Results. In Figure 2, it shows the electronic density difference for different, different terminations studied in this work. In Figure 3, the partial density of the electronic states per spin channel it is present for the LTO and LTO perovskite 001 surfaces. In Figure 4, it presents the surface gram potentials for two surfaces, dioxide, titanium dioxide and lanthanum oxide terminator for LTO perovskites. And Figure 6, it is shown the surface gram potential for the different termination of LTO001 surfaces. Conclusions. These results show that the surfaces reconstruction changed the electronic properties of the titanium dioxide and lithium oxide terminate of LTO surfaces from those of the bulk, as well as that charge redistribution modulates the physical behaviors of the titanium dioxide and lanthanum oxide terminate LTO and lanthanum oxide terminate LTO surfaces. Figures 1 and 3. Titanium dioxide termination is the most likely for LTO at the 001 free surface, but is the most unstable for LTO surfaces. Figures 4 and 5. Thanks for watching.